Okay, the word problems. Okay, here's a table of the distances in meters for all the diameters of all of the planets. So that diameter is how far across it is, how many meters it is across. Okay, so write the planets in order from smallest to largest. So we want to go small to big. Okay, well first of all, let me look at the powers. That's 6 decimals. So 7 decimals is bigger. 8 decimals is even bigger. So it looks like the 3 smallest ones is that one, and that one. Pluto, Mars, and Mercury are all power 6. Okay, so this is a 4. So see, if I move that 6 places, 1, 2, it's got 4 more zeros. So that's really 4, 8, 8 with 4 more zeros. This one is 1, 2 with 4 more zeros. So Mars is 6, 7, 9 with 4 more zeros. And then Pluto, if I move it 1, and then it'll have 5 more zeros, so it'll be 2, 3, 1, 2, 3, 4, 5. Okay, that's 2,300,000, 6 million, 4 million. Smallest, medium, next. So it's all of the super smalls. Pluto's the smallest. Mercury is next. And Mars is next. So there's the first 3 small ones. Those are the 6s. Okay, now I'll do the 7s. There's a 7, there's a 7, there's a 7, and there's a 7. So see, the giant ones are the ones with the 8. There's 2 giants, Jupiter and Saturn. Those are going to be the biggest. Okay, so let's take a look at this. Let's just say it's 7 moves, but it starts with a 1 with 7 moves. This starts with a 5 with 7 moves, and this is a 4 with 7 moves. So the smallest would be the 1 with 7 movements, and then the 4 with 7 movements, and then the 5. So the smallest of these, let's see, I have 121 and 128. These are almost tied. Okay, well 121 is smaller than 128, so Venus is smaller than Earth, and then the 496 is next, and the 512 is next. So 121 is Venus, Earth. Then between these, I got a 496 and a 512. So the 496 is Neptune, then Uranus. Okay, so I got those done, and now the last ones are, there's an 8 and there's an 8. So those have 8 decimal moves. This is 1.2, this is 1.4, so this one is smaller. So Saturn is next, and Jupiter is the biggest. Okay, about how many times larger is Jupiter than Pluto? How many times? You could think of it like this. How many times larger is 10 than 2? So it would be 5 times larger. The way our brain did this is we take this one and divide it by this one. We would take 10 divided by 2. Okay, so we have to do that with Jupiter. We need Jupiter divided by Pluto. So Jupiter is right here. 1.43 times 10 to the 8 divided by Pluto, which is 2.3 times 10 to the 6. Okay, divide is subtract the powers. So I already know the power is 8 minus 6. I already know it's times 10 to the 2. And then I'm going to go ahead and do this on my calculator. 143 divided by 2.6. (143) divided by 2.3, sorry, is 0.62. Okay, so what does this actually mean? It means move the decimal 2 times. So 1, 2, that means it's 62 times larger. Now that means just the diameters. It doesn't mean, so like if this is Jupiter and this is Pluto, 62 Plutos will fit across Jupiter. So how many times larger is Jupiter than Earth? It's the same question. It's like, how many times larger is 10 than 2? We're going to divide them. So we're going to take Jupiter divided by Earth. So we have 1.43. I'm going to divide it by Earth, which is 1.28 times 10 to the 7. Okay, division is subtract. So I already know the power is going to be 8 minus 7. So the power is times 10 to the 1. And I'm going to use my calculator for that. 143 divided by 128 is 1.12. We'll just round it right there to 1.12. Okay, this means move the decimal one time. So when I move it one time, it makes it about 11.2 times larger. So 11 Earths will fit, if this is Jupiter, 11 Earths will fit across there. 62 Plutos will fit across there, but only 11 Earths will fit across there. Okay, pretend a new planet was discovered, and the diameter is Pluto squared. So Pluto is squared means power 2. So if I just take Pluto, which is right here, 2.3 times 10 to the 6, and square it, okay, we just did a bunch of those up there. Power is multiply, so that's times 10 to the 12. And then we got to put the 2.3 squared out there. This is what our calculator is for. So 2.3 to the second power is 5.29. So 5.29 times 10 to the 12. Okay, it would be silly to write that out with 10 zeros, so we would just leave. This is what scientific notation is for. See, it's not silly here. 0.62 is 62. 1.1 is 11. Here, we don't need to write all those zeros because that's harder to read. We want to write it in the easiest to read possible fashion. Okay, number 15, you must show your work. Okay, let's see. You go to the fish store and buy a fish tank. Holds 171 liters of water. Inside the wrapping it says it would take, whatever number that is, 7 quadrillion tanks of this size to fill up the ocean. How much water is in the ocean? What if it would have said it would have taken 100 tanks to fill up the ocean? We would have done 175 times 100. Well, it's the same thing. We're going to take 175 times that gigantic number. So 175 times this number, 7.43 times 10 to the 18. Okay, when you do multiply, you add the powers. So we got 10 to the 18th, and then this one doesn't really have an exponent on it. So I'm going to add the powers. It's 18 plus no power. So I already know it's 10 to the 18. See, we can think of that 175 as times 10 to nothing. Don't move it. Move 0. So 18 plus 0 is still 18. And then I need my calculator for that part. So 175 times 7.43.
Yeah.
175 times 7.43. 1323.8. Okay, that would be okay, but I'm not going to write out 17 more zeros. That would be silly. So I'm just going to fix it. So I'm going to answer this as 1.323. So move it 3 places that way. Means the 18 gets moved 3 places that way, becomes 21. That much water is in the earth, is on the earth. It's a large, giant number. Your friend goes to the same store and buys a 75-liter tank. How many of these tanks would it take to fill the world's oceans? Okay. Okay, so how many of these tanks? So we have this number right here's how much the ocean is, and we would like to divide it into 75-liter chunks. We have the giant ocean with this much water, and we're trying to take out a 75 chunk, another 75 chunk, another 75 chunk. So we'd like to know how much water, this is how much water are 75 chunks. Okay, well, division is subtraction. I could write that 75 as 0 decimal moves. So the subtraction is 21 minus 0, so I already know it's times 10 to the 21 still. But I need my calculator for that part. 1.323 divided by 75. Is 0.0176. 01764. Okay, that's fine. I'm just going to fix it. I'm going to call it 1.764. I move the decimal that way twice. The 21 is going to go that way twice to become 19. Okay, according to healthcare.com, the average person produces 1.5 liters of snot per day. There are 7 billion people on Earth. See, that's a 7 with 9 zeros. How many liters of snot are produced every day? Okay, well there's 1.5 liters per person, and we're going to multiply that times 7 times 10 to the 9 times 7 billion. Basically, we're taking 1.5 times 7 billion. Okay, well, multiply says add the powers. Remember, again, I can think of this 1.5 as times 10 to the 0 because it's a 0 move. So 9 plus 0, I already know it's times 10 to the 9, and I'll use my calculator for 7 times 1.5. So 7 times 1.5 is 10.5. Going to fix it, so go 1 that way, so it's 1.05. That means the 9 goes 1 that way to make it a 10. A swimming pool holds approximately 660,000 liters of water. How many swimming pools of snot can we have? Okay, what if it said, so we have a swimming pool can hold this much. We have this giant pile of snot, and we have a bunch of swimming pools. If we take the giant pile of snot, here it is, we want to see how many swimming pools are worth of snot that is. So that's a division problem. So we have a 1.05 times 10 to the 10, and we want to divide it by 160,000. Okay, you might actually be able to type that into your calculator, but we don't have to because we can add this 10 to the 0 there, 160,000. We don't want to move. Division means subtraction, so 10 minus 0. I know it's going to be 10 to the 10. And now I'm going to use my calculator just for this part. 1.05 divided by 60,000. It's 160,000. So 1.05 divided by 160,000. Okay, 0.0000656. Okay, so 0.0000656. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 zeros. But that's not how we leave it. We're going to fix it and move the thing so it's 6.56. So that's 1, 2, 3, 4, 5, 6 moves this direction. That means the 10 is going to go 6 moves that direction, so that makes it only 4. Now this would be an okay way to leave it, but now we're getting down to a spot where you can almost write that the other way. 4 means move it 4 to the right. 1, 2, so that'd be 2 more zeros. So 6, 5, 6, 0, 0. See, that sometimes is, if it is a nice number, sometimes that helps. It'd be 65, so 65,600 swimming pools worth of boogers every day on the planet. That's a lot of snot. Just think of swimming in the swimming pool full of snot, 65,000 of them. Okay, there's this many square miles on Earth. Lots. There's a lot of square miles. Move the decimal 7. There's approximately this many trees, so move the decimal 4. Now, I don't know why I changed this to 7.7. Right up here, I already told you how many were on Earth, but this is actually, I Googled it and got a little more accurate. There's 7.7 billion people on Earth. Okay, how many trees are on Earth? Okay, there's this many miles and this many trees per mile. So if we multiply those together, we should know how many trees. So we have 5.7 times 5.33. And I know that multiply is add the power. So I already know the power is 11. And now I'm going to use my machine for 533 times 5.7. So 5.33 times 5.7 is 30.381. Okay, fix that. One spot that way, so it's 3.0381. Move the 11 one spot that way, makes it 12. Lot of trees. How many trees are there for every person on Earth? Okay, so there's this many people. So I have this gazillion amount of trees and this billion amount of people. So if I take all of those trees, divide it by all of the people, we have the number. Divide is subtract to the power. So 12 minus 9, I already know it's times 10 to the 3. I'll use my machine for this part. 30381. So let's see here. 3.0381 and divide that by 7.7. 0.39. Okay, this means move the decimal 3 places, so 1, 2, 3 makes it 390 trees for everybody on Earth. So we all have 390 trees. Okay, we've got 5 billion trees are cut down each year. 9 zeros. At this rate, how long is it before every tree is gone? So, okay, we figured out how many trees there are right there, and we're cutting them down this much a year. So if we divide those two numbers, we'll know how long it takes. 3.0381. If I want to divide it by 5 times 10 to the 9. Okay, I already know that division is subtract, so 12 minus 9, so I already know the power is 10 to the 3. And now I'm going to use my machine for the other part. So we have 3.0381 divided by 5. That's about 0.61. Okay, if we move the decimal 3 places, 1, 2, 3, that's 610 years. Now that seems like a long time, but you know, we're going to have no oxygen way before the last tree's cut down. So yes, it would take 610 years to cut down every last tree, but we'll be dead long before that.